Okay, so now we're actually going to build up a family of curves, and we're going to start with electrolytic capacitor number 1. They're all the same value, they're all the same pretty much identical components, so we're just going to see how the performance of them varies between each other. So when we're working with electrolytic capacitors, you want to set up your signal generator accordingly. And one of the things you need to do is put a little bit of a bias voltage on the capacitor. So for this application, a half a volt will work. You can see up here I've got 0.5. So that'll work. We're using circuit A, like we did before. And for the first sweep, what we're going to do is click the auto setup button. Okay, so the system will automatically set up itself. It's going to look a little strange while it's scanning, but then it'll resize the two traces appropriately. And then on subsequent sweeps, we're going to uncheck the auto setup, and you'll see that they'll just all fall in together as we go. So I'm going to click Start Sweep now, and we'll just watch the whole thing work. Here it goes. Keep your eye also on the scope display, because you can see the excitation and the response from this whole thing. And so now it's sweeping across from 10 hertz to 10 kilohertz. We can see as the graph builds up, it goes along. And then when it gets all done, I'll show you what we do next. Now you can see how it's progressing in this area right here. It says it's sweeping, and then it waits, and it's sweeping. When it's done, it'll tell you it's done. And then there you go. So that it auto-sized. So the first thing we're going to do is going to remember to click off auto setup up there. Okay, so here, what I'm going to do here is just click this, which is normalizing the scales to the graph. And then what I'm going to do here is I'm going to save this by first clicking Add Reference here, and then Add Reference there. Okay, so now we've basically saved these two. All right, the next thing I'm going to do is I'm going to try to label each one of these traces, and then we're going to come back and scan all the rest of them. All right, so stand by, and we'll be back in a minute. Okay, so we've completed testing 4 different capacitors and generated our curve family here. Just a reminder, on capacitors 2, 3, and 4, we unchecked auto setup, but we left all the other settings the same. Okay, so now you can see over here that we have 4 distinct curves for both the capacitance value and for the dissipation. What I'm going to do is I'm going to enlarge this so you can see more right in here. So the handy little black cursor ball right here is tracking capacitor number 1, and right here at 100 hertz you can see that it's 498.5 microfarads. And if you tab down, you can then get your dissipation number or dissipation factor right here at 100 hertz on the same capacitor. Now to change to a different capacitor, we're just going to go and click on number 2. So this, I kept them in order. So this is now the trace for number 2 capacitor is highlighted over here, as you can see, and the same thing up here for the microfarad value right there too. So this is how you do it. After each run, you add reference right there to each of the 2 traces, and then this counter here tells you which one that you're in. So this would be for capacitor number 3, and this is for capacitor number 4 right there. So you can just click around and keep track of how many that you wanted to do. And of course you can you can change your scales and so forth if you want to see a little bit more detail, in between the different capacitors, or the dissipation factors for each one of them too, so you can see what's going on here. So it's just a variation between units. Probably they're all okay, but at least this tells you exactly what's going on across the region of interest of frequencies.